Hello everyone, my name is Marcelo Sacchetin. Today I'm going to be talking about ChupaCarBrah. It is a open source do-it-yourself tool for interacting with automotive CAN bus. Just a quick disclaimer, this presentation is based solely on my opinions. It has nothing to do with my employer. And keep in mind, if you attempt to do the things that I'm covering here, you might potentially damage your vehicle. And keep in mind, if you damage your vehicle, malfunctions may or may not incur in safety issues for you and others. So be careful if you attempt doing stuff here. I cannot accept the risks. Okay, a little bit about me. I'm a security engineer. I do secure development lifecycle. I work close with the dev teams on my daily basis to make sure they write secure code and applications. I try to do a lot of automation with Python, and we're gonna, and surprise, surprise, the ChupaCarBrah that I develop is uses Python a lot. And my first exposure to CAN, to the CAN protocol, was a while ago when I was a secured software engineer, and I developed some industrial control software. And we know that a lot of PLCs rely on the CAN open protocol for communication. I also like building stuff with single board open source hardware, such as BeagleBone and Raspberry Pi. And one of the cool things that I built was some coding bots, so I could teach my kids learning Python. And this is what brought me here, because I attempted to, when I tried first to do some CAN hacking, I researched, and CANTACT was the most known tool for doing that. And because of, but it was sold out on a lot of vendors. And they even mentioned it was because of DEF CON. It was really interesting. And then I remember that one of those bots that I built for my kids, I used the BeagleBone Blue, which had embedded CAN controller and the transceiver on it. So, and I thought, considering options, and I said, well, why not try doing that using a BeagleBone Blue rather than waiting longer to be able to buy the CANTACT. So, this presentation is about how to use BeagleBone Blue, SocketCAN, and Python CAN to interact with the CAN bus on your vehicle, more specifically to the OBD-II CAN bus. At the end, I will bring some research I have ongoing, still ongoing, no solid results, but trying to connect to ECUs directly. It is possible, but it's still an ongoing work. And I plan to make it interesting for both newcomers like me that are attempting car hacking for the first time. So the ChupaCarBrah is easy enough to build and plug into your car and start doing stuff. But it could be very useful for more experienced hackers as well, because since it's a single board computer, you could easily extend it to different applications or use cases that you might have when you're doing your hacking. So all the ChupaCarBrah code is available on GitHub. So if you're an expert, chances are that all you need to know from this presentation is this URL, so you can take a look on the code. And also on GitHub, I share a link to a Hackster.io tutorial that I wrote with very detailed step-by-step instructions, so you can build a ChupaCarBrah device exactly to the one that we're gonna covering today. And I hope I'm going to share the mistakes that I made when I was attempting to do it for the first time. And hopefully it will help others when trying to do that. And with a device easy enough to build, potentially we can engage more people on attempting car hacking and growing the community. So this is the device. It's basically a big old bone, as you can see here, with some add-ons. So basically I connected a USB cellular modem here on the USB jack. I connect a DC jack here, so I get power from the OBD-II port on my car. And of course, I will need a ODB connector to connect it to my car. And here, this is the CAN port on the Big Ol' Bone Blue. So all you need to do is to connect a JSTISH cable here, and then on the back you connect it to your OBD-II extension cable. Of course, you can wire it directly to, this is the back of the device. We can also see that I use a battery. It's completely optional, but you can use it even if you're, let's say you are building a car tracking application. So, and even after your car batteries die, using the battery, your Big Ol' Bone will be still alive, and you can still track the GPS coordinates with this GPS module here and potentially recover your car if that is your goal. So I use it very simple material. So I use a plastic plate like this to put all the pieces together, some rubber bands, but you can build it differently. Again, all the instructions are on the Hackster.io article, and all you need to do is to put all those pieces together so you have a functioning Big Ol' Bone to plug to your OBD-II port on your car. So, and also you don't need to do add all those parts together. I would say if all you want to do is to just use SocketCAN to run some exchange some CAN messages with your car, all you need to do is, of course, the Big Ol' Bone Blue and a connector like this. The name is JSTISH connector. You connect it to one end to the Big Ol' Bone, and then you can use solid hookup wires like this to connect it to this connector, and then the other end directly to the ODB ports to your car, if you want to keep things simple. Or you can just build it using the OBD-II extension like this. Okay, so what does, once you build your device, what does it do? So the idea here is to create a connection between your CAN bus from inside your vehicle to the outside world. So from my perspective, I can assume that most of the manufacturers create a threat modeling of their CAN bus system, assuming that they are going to be isolated from the outside world. So of course, you would need physical access to the car, but the idea here is to create an easy way so you can exfiltrate data from your car to the CAN bus. And the Big Ol' Bone Blue makes it very convenient because it's really easy to connect the GPS module that I showed before. And on the top of that, it already has the embedded Wi-Fi access point and interface, so you can connect it directly or connect it to your Wi-Fi network and access the internet. Or as I showed, you could use a cellular modem like this to the USB port. And even if your car drives away and goes out of the range of your Wi-Fi network, you still have communication to your vehicle and you would be able to potentially send CAN message to your car remotely. And one other cool thing about doing it using a single board computer, you can easily expand it to some other different applications. You can, for instance, create a geofence application. You want to maybe disable your car if it goes too far, or maybe you want to track it back. You can, for instance, plug USB cameras and microphones. So if you want to capture audio, you can even use servos, because the BeagleBone Blue is a robotic, it's intended for robotic applications. So you can plug servos here on those rails and perform some physical actions inside your car if you need it. You can even try to robotify your car, let's put that way. So this is what it, this is what it does. And once we run the ChupaCarBrah inside your car, you're gonna see on your local terminal, I'm assuming you SSH to your BeagleBone, and you're gonna see, once you run the Python script, you're gonna see on your terminal what we have on the left. By default, it will start monitoring your vehicle speed from the OBD-II port, the RPM, and the temperature. And we'll also start sending all that information along with the GPS coordinates to a Flask application running on AWS. The source code for the Flask application is also available on the GitHub repo. So as I mentioned, by default, it will send only vehicle speed, temperature, and RPM. But if you want to use other OBD-II PID from your OBD-II port, I created this convenient CSV file that if on the left column here on the enable disabled column, you just set 0 and 1s to the OBD-II PIDs that you want to enable or disable. So as you can see here, this is one example. And all you need to do is customize it, and then you should be able to monitor other information from the OBD-II port other than the speed, temperature, and temperature. Okay, so how do you connect a BeagleBone to your OBD-II port? As I mentioned before, you have the CAN connector here. You use the JST connector to plug it here. And then all you need to do is to go to the female OBD-II port on your car and connect the CAN high and CAN low pins to the pin 6 and 14 respectively on your OBD-II port on your car. And it brings me to the first mistake I made. Keep in mind that this schematic, these pin numbers are related to the female OBD-II port. So initially, what I tried to do, as you can see here on this picture, I connected the JST connector to the BeagleBone, and I used some hookup cables, and I cut a cable like this, and for convenience, I would connect my BeagleBone hookup wires to a male OBD-II connector. And keep in mind, if you do that, the numbers 1 to 8 will be mirrored, because the female connects front to front to the male, and female connects like this. So the 8th pin here on the female is actually the 3rd pin here on the male. So keep those things in mind. This is a mistake that I made, and I believe I want to just prevent you to wasting time doing troubleshooting those things. And other mistakes that I did, and it could potentially help you when attempting this. So use a multimeter is your friend. I would be able to easily catch up that mistake if you use a multimeter and make sure you have some voltage on the pins that you want to tapping. And by the way, on my car, the pins 3 and 11 that I connected by mistake initially, they don't have any voltage there because they don't do anything. So with a multimeter, you would be able to catch issues like this. Another mistake that I did was when I saw CAN dump, I assumed TCP dump. So it's a sniffer, right? Sniffing traffic, so they should be similar. They are in some extent. However, CAN bus is not Ethernet. You need at minimum 2 nodes on the bus so you can potentially transmit and sniff some traffic. So initially, I enabled the CAN interface on my BeagleBone, started CAN dump on one terminal, I started doing CAN send on the other, and I didn't see anything, and I didn't know why. The reason is because you need 2 nodes, so you have at minimum, so you have a CAN. But even before doing that, what I would recommend, play a little bit with vCAN first. It's very easy to install vCAN on a Ubuntu Linux, for instance, and then you can do the CAN send, and CAN dump, and monitor the messages and understand how it works before even attempting to a real physical CAN. Another common issue that I had to face is you have to know the bit rate. So if you want to CAN bus to work properly, and for my vehicle, by default, it uses 500K baud rate, and yours might be different, so keep that in mind. So this is a suggestion. So if you want to make sure your ChupaCarBrah is working and you understand a little bit how CAN works, create a CAN bus breadboard like this. It's really simple. You just use use some jump wires to hook your JST connectors to a breadboard. The only thing you need to know is I'm using blue for CAN high here and white for CAN low. The only thing that you need to know is you need a 120 ohms resistor at the end connecting the CAN high, at each end connecting the CAN high and CAN low rails. It's going to be very helpful because then you can plug 2 BeagleBones, for instance, and exchange some CAN messages between each other with CAN dump. Another useful thing that I would recommend, not necessarily, but it might be helpful, is to cut a extension cable like this. So if things are not working properly, for instance, my first, I bought a very simple device like this. It's a scan tool that supports CAN OBD-II. It's very cheap. And it was working, and I didn't know why my BeagleBone wasn't working properly. So I created this, I cut this cable and hooked 1 through 16, all the pins on my breadboard rails. And then I was able to connect this device to this extension, and the extension to the car. And then here on the picture with the zoom, I could hook the JST connector to this breadboard, and then start CAN dump there. And for instance, use this device to retrieve the VIN number, and then I would see the exactly messages that it was exchanging and understand what could be wrong on my BeagleBone that I wasn't getting right. And in my case, what I didn't know at that time was this. I was expecting to plug the BeagleBone to the OBD-II port, start CAN dump, and I was expecting to see a lot of traffic there. But what I noticed is that my OBD-II port was silent. It was just listening to, because it was segmented to the other CAN buses on the car. So it was just waiting for some specific CAN messages to reply to it. And this is exactly what happened. This is when I sniffed the comments from this device here, that was the CAN message I saw. And then using the CAN dump on the CAN 0 from the BeagleBone, I saw the request and the response with my VIN number there. Yeah, so, all right, so let's say you're confident enough, you understand how to play with CAN bus using a BeagleBone, and now you wanna, and you built your ChupaCARBrah device and you wanna run it on your vehicle. So my suggestion would be play a little bit first with a SocketCAN and make sure everything is working. So just try different bit rates. For instance, here on this, I'm trying the 500K, which is what worked for my car. Enable the CAN 0 interface and open another terminal with CAN dump, and on a different terminal you send the request VIN message. And by the way, all those messages, including this request VIN, is available on the CSV worksheet that I have available on GitHub. So you can try different stuff there. Once you know, once you see the request and the response, you know that your ChupaCARBrah and your BeagleBone is able to properly use SocketCAN in your car. And then if you want to test the GPS module, you would recommend using this TIO command. By default, it uses the serial port TTY02 with baud rate 4800. This is a specific one that I use it. All the parts are listed on the Hackster.io article, and I point to vendors that supply them. So, and when you start the TIO command, you're going to see a lot of GPS sentences flowing around. And wait a little bit for the module to find a GPS satellite. And once you get some GPRMC sentences, similarly to this one that I have on screen, you can use a online decoder, just like this RL.SC. It's really cool, by the way. You just need to provide the GPRMC and it will plot your exact locations on a map. For cellular connection, so for connection, all you need to do is to make sure you have internet connection from your BeagleBone, either by using Wi-Fi network or a cellular LTE modem, which is what I did. I used the hologram vendor because it's very Python friendly. The documentation is really good. So it was really easy to install it and get it working on my BeagleBone. Again, all the documentation is available on my Hackster.io article. And at the end of the day, all you need to do is to ping a public server on the internet and make sure you have internet connection, so the data that your ChupaCARBrah is capturing can be exfiltrated to a server. And once you know everything is working properly, it is time for you to clone the repo. Go to the ChupaCARBrah folder and play around a little bit with the CSV files and enable and disable the OBD-II PIDs that you are interested in, and then just run the Python script. And by the way, it's all Python 3 based. I don't think it works with Python 2. And if everything goes well, we're going to see all the OBD-II PIDs that you enabled being displayed on the screen. And also, if you have an internet connection, by default, it's going to be exfiltrated to this public AWS Flask app that I have running. And by default, the script points to that. If you want to create your own, just use the code available on this server, or on this GitHub repo. And then you can customize it, run in a different cloud environment, and customize it any way you want. Okay, let me run a quick demo video here so we have an idea how the ChupaCARBrah works. So this is the device. I'm gonna plug into the OBD-II port from my car. The engine is on, already running. yeah, so I'm just showing where is the OBD-II port on my vehicle. It's usually some close to the steering wheel. And then I'm going to put it on the dashboard because I'm going to monitor it from outside the vehicle. This is something that is really convenient compared to the other solutions, because you have the embedded Wi-Fi access point on the BeagleBone. You can just connect to it and run ChupaCarBrah from there. This is what you would get on your terminal if everything goes well. And then you can monitor your car. Of course, if it goes out of range, it won't work, but you can monitor your OBD-II data from outside the car. And now I have a test from inside the car. Here is I'm running the same test from inside the car, but the cool thing here is I perform a lap around the course, and I'm monitoring the GPS data. So it's exfiltrating using the cellular network to the AWS server that I had running, right? And you're gonna freeze the video exactly where the coordinates was exfiltrated. Then when I got home, I just visited the public AWS Flask application, and I saw all the GPRMC sentences available there, and I could plot them on the map. So if I was away from the vehicle, I would be able to track it wherever it was. And if you plot all the, GPS will also give you the speed. And if you plot all the coordinates that are available in the application, you would have an idea from where the vehicle was traveling. So I performed a course around a few blocks, and this is what I show here. All right. So this is how the device works, right? So it is able to exfiltrate OBD-II and GPS data. But what's next? And this is a currently work. I have only preliminary results, but probably the next thing that you want to do is to go beyond of the OBD-II CAN bus and actually tap into a real CAN bus for your vehicle. And you can do it using the exactly same device. So what I've been doing so far, so rather than reverse engineering every wire inside and disassembling my dashboard, that would be insane hard work to do, you can alternatively go to your dealership and get a book like this, a supplemental, electric supplemental manual, and it will give you a lot of detailed information about all the cables, where all the electronic components from your vehicles are located, and the connections between them. So for instance, really close to my steering wheel on my vehicle, I have this ETEX ECU that is also located pretty close to the OBD-II connector. So I thought, okay, let me connect those two CAN buses that are segmented from my vehicle, and then I can monitor everything. And that was my goal. So knowing where the ECU is pretty, it helps a lot. And here is a picture of the vehicle. So to get physical access to that specific ECU, all I needed to do was to remove a couple of plastic covers from my vehicle, and that was it. I could see the ECU from the bottom of the driving seat. And also, the electronic supplemental will give you detailed information about the ECUs on your car. So for this one specifically, if you look to the picture on the left, on the bottom, I have this C411 connector. And if you go deep on the manual, you're going to notice then on the diagram on the right, on the top, you have, you would know that the C411 connector is actually connected to a CAN drive. And the pins 8 and 9 are connected respectively to CAN low and high to another component they call ECM on this vehicle. And not only that, you know, you have the wiring colors used for those cables. So I know that the CAN high on pin 9 is BR, which is brown cable, and the CAN low on pin 8 is a Y, a yellow cable. So looking carefully to inside my dashboard, I was able to find this ETAX ECU with this specific connector. And you can see the brown and yellow cable on pins 8 and 9. And also close to the arrow that I put, you can see the OBD-II port on the top. So again, so what I needed to do, all I needed to do is to use a hookup wire like this. This is not the actual CAN cable, it's just a hookup wire that I manually twisted myself. Oh, this is another common mistake. Make sure your you either use a real CAN cable, or if you're using hookup wires like me, make sure they are not too long because they might not function well. And you can try to manually twist them to mimic what a real CAN cable would, the physical properties of a real CAN cable. But back to this, be aware that by bridging those segmented CAN buses on your car, you might damage your electronic components on your car and incur in safety issues for you and for others. So be sure you know what you're doing and be careful. Okay, so once I got a good physical connection with those pins, I used a multimeter to make sure I had good wiring. On this specific ECU, when I have the ignition off, it gives me 1.13 volts, but when I turn the ignition on, I get the expected 2.5 volts. Another mistake that I did, I recommend turning on the engine because you would very quick kill your battery. I did that. Don't make the mistakes that I did. Okay, so now that I know with the multimeter that I have a good physical connection with the ECU, I connected the other end of the hookup wires directly to the back of the big old bone with the other, with the existing CAN high and CAN low cables wires that I had to the OBD-II. And that's all I needed to do. And then by doing that, as opposed to the initial result that I had only with the CAN, the OBD-II CAN, now if I run CAN dump from the ChupaCarBrah device, now I see a lot of traffic between this ETAX ECU that I connected and the other electronic device ECM from my vehicle. I can tell, I can guess it's the engine and this other ECU communicating and exchanging information through the CAN bus. All right, so so that's what I got so far. What I'm planning to do, that's what I'm trying to do right now is to reverse engineering some of those messages. For instance, I'm trying to use a CAN dump to write to save the traffic to dump the traffic to a local file, do something on the vehicle, for instance, opening and closing the power window, and then using CAN player, try to replay the traffic and try to open and close the window just by replaying the messages. The problem is I wasn't so successful doing that so far, and every time I try that, I get a beautiful and shining service engine light on my vehicle, and I might break my vehicle at some point. And not only that, maybe I'm not even connected to the right CAN bus that I should be tapping into if I want to open and close the window. So I have a lot of work to do that yet. But what tells me I'm on the right path is when I do CAN sniffer, unfortunately, because it's a very busy CAN bus, it's still very polluted to me to tell exactly what's going on when I open and close the window, but I see something go, some action there, some difference, some new messages showing up when I'm doing those actions. So I still don't know what's going on, but that's what I'm trying to do. Get some interesting CAN messages so I can replay them later. So since I wasn't able to get for instance, the opening and closing window yet, let's assume the message that I want to do remote execution on my car is the retrieve VIN message, right? Which is the one I'm highlighting here with the CAN send command. So my goal is to create a kind of RPC where I have a new endpoint on the Flask application running on the cloud that I would be able to send any CAN message that I wanted to be executed remotely on the car. Of course, I had to URL encode the hashtag here so I could post this URL to my Flask application and get it available. And in order to do that, here's a oversimplified version of the changes that would be needed on the current ChupaCarBrah implementation. Yeah, and by the way, once I get it working, I will update the code and make it available. But if community guys, if you feel free to fork the code or even submit pull requests, I would be very excited if people would start doing that, actually. But the idea here is to do what I showed before, submitting messages remotely to create this kind of reverse HTTP command and control. I would create on the server application a queue and two new endpoints, a get and post endpoint on this RPC endpoint. And whenever you send a post message with the CAN message, it would add to the queue. And then on the get request, you would pop a CAN message from the queue, and potentially, and then you execute it on the client. So the changes on the client, the ChupaCarBrah.py, would be basically hitting the RPC Flask application with a GET request. It would give you a keyword CAN message that you submitted, and then it would send it to the bus and execute on your car. Of course, this is a very oversimplified version. Just to illustrate, you would need to add some error catches here, some logic, and even you would need to parse the JSON data to put your CAN message together. But that's the idea. So this is one suggestion. This is what I'm going for. But again, it's a Python code on a open source hardware platform. Feel free to do whatever you want to do with it, right? And the takeaways here from this presentation is, again, I want to build a open source hardware and software platform that could be useful for newcomers that are attempting this for the first time, but also for more experienced guys that see a need for a single board computer running on a car where they could remotely do some stuff there. Currently, I only, the code that I have on GitHub only do GPS and OBD-II CAN messages data exfiltration, but I has just showed I plan to expand it in the future. Yeah, so let's use it, guys. I'm open to feedback. Let's grow the community and let's have fun. One thing I would like to thank my friend Robert from Autobahn AI. He helped me a lot with all his knowledge on automatic CAN with issues that I have, troubleshooting things and attempt different approaches. So thank you, Robert. It was really appreciated. And that's all I have, guys. So again, all the information that you need to build the ChupaCARBrah is available on GitHub. And if you have any questions, suggestions, hit me on social media. I would be very happy to see people using the device, and if people have the same issue that I have trying to buy other open source tools because they were sold out, let's make BeagleBone sold out. I'm going to measure the success of this presentation based on whether or not we can sold out all the BeagleBone Blues next year, because everybody will be trying to hack their cars using this open source platform. So again, thank you, guys. I'm open for questions. Reach out to me either on social media or on the Q&A session.